Good morning, everyone. In this video, we'll be talking about use case models. We'll be looking at what are actors, what are use cases, what are use case diagrams. Okay, so let's look at them. An actor is a direct external user of a system. Okay, so if there is a system, an actor is an external user of the system. He is not involved within the system. I mean, he is involved in the system, but he is not part of a system. Okay, an object is a set of objects that actually communicate directly with the system but not part of the system. Okay, so again, see here we are thinking in terms of object oriented design concepts. Okay, so again, like these actors are also objects. Okay, an object or a set of objects that communicate directly with the system. Okay, think about a vending machine. Okay, so we are developing a system for vending machine. Okay, so the vending machine basically it has different items. It has to give us the items provided, like we select for an item and we pay for it. Okay, they're like the customers. Okay, the customer is an actor for such a vending machine system. Okay, similarly a repair technician who will be fixing the things. Okay, so are like who will be doing the regular maintenance of this vending machine is also an actor. Okay, so the customer and repair technicians are different actors for the vending machines. Similarly, if you are thinking in terms of a travel agency system, okay, so the actors for that one will be like the traveler would be one actor, the agent who is making all those I mean, so who is invoking the system is also an actor, and the airlines is also an actor for that, for such a travel agency system. Actors need not be persons always. I mean, actors can be persons, devices, and also other systems. Okay, so let's look at them in detail. An object can be bound to multiple actors if it has different facets to its behavior. Okay, so think about this situation. Say, for example, there are three customers here, Alice, Bob, and say, for example, Satish. They may be the customers for this sort of vending machine. Okay, but at the same time, like Bob has a different facet. Okay, so the Bob may also be a repair technician. So in that case, like Alice being a person and an object, okay, so it is bound to one actor, but then like Bob is bound to two actors. Okay, say for example, there like he is customer and also like that repair technician. Okay, so that's what this having this. I mean, like they can be bound to an object can be bound to multiple actors. Generally, I mean, an actor has a single well-defined purpose. What the part of the system it is actually trying to interact with. Okay, so it is very clearly defined. Okay, each actor represents a coherent set of capabilities of its objects. Okay, and for that particular object the actor very clearly says like what is the set of capabilities, okay, that the object can perform or like the actor can perform on the system. Okay, modeling actors is very important actually. Okay, so modeling the actors actually helps you define what is within the system, okay, and what is outside the system. Those are the boundaries of the system. Okay, so those objects which are on the boundary. Okay, so that's why, like say for example, modeling of the actors is very critical. Okay, that's about actors. Now let us discuss about use cases. A use case is a coherent piece of functionality that a system can actually provide. Okay, and it has to basically will be interacting with the actors. Okay, it's a coherent piece of functionality that a system can provide. Say for example, a customer actor can buy a beverage from a vending machine. So the vending machine system actually allows one set of functionality, which is buying a beverage. Okay, and the customer being an actor can actually invoke that functionality. Okay, or the customer can interact with the system. Okay, by invoking that functionality. Similarly, a repair technician can perform scheduled maintenance. Okay, so that's also perform scheduled maintenance is also an use case. Okay, on a vending machine. Okay, these are basic use case examples. But now, if we really try to summarize what these operations are doing, more or less like what these functionalities are, what these use cases are. Say for example, for that particular vending machine, so we have four different types of use cases. Buy a beverage, its description is the vending machine will deliver a beverage after a customer selects and pays for it. Okay, we need to have simple descriptions. Okay, so but of course, like use case modeling, okay, use case models will contain all this sort of basic information of an application. We have already discussed when we were talking about these interaction models. So that's about buy a beverage. Again, like this perform scheduled maintenance is also another use case. A repair technician basically performs the periodic service on the vending machine necessary to keep it in good working condition. That is this use case of perform scheduled maintenance. Then the other use cases are, say for example, this make repairs. Again, the repair technician performs this unexpected service on the vending machine. Say for example, whenever there is a problem, he has to do this sort of he has to provide that service so that like it gets back to functioning. And you will also have the description for that one, make repairs. Similarly, load items. So when the stock is basically finished, a stock clerk will be there, again like another actor. Okay, adds items into the vending machine. Okay, so for the whatever the items, whatever the stock beverages stock basically comes gets reduced, he basically adds more to this one. Loading, he loads the items. So these are different use cases which are within this system. Buying a beverage, perform scheduled maintenance, and make repairs and loading the items. And we have the description for that. Each use case involves one or more actors, okay, as well as the system itself, of course. Like, okay, say for example, you think about a telephony system. The use case make a call actually involves a caller, one activity, and a receiver, another actor. Okay, sorry, both are actors. Okay, so the make a call use case actually involves this caller and then like receiver actors. So multiple actors are involved here. Okay. As I already mentioned, the actors need not be persons always. I mean, like until now, like I have been more or less like the examples which I have given are similes. Actors are approximately persons. But of course, like I have also talked about the travel agent system where like the customer agent and then like the airline is also an actor there. So that already might have given you an example. Similarly, like if you are considering a stockbroker system, for the use case make a trade, okay, would be the use case. This need to communicate with the customer actor and the stock exchange actor. The stock exchange is actually a system on its own. Okay, so that's about it. So basically, actors just don't have to be persons always. Okay, let's move on. A use case actually involves a sequence of messages among the system and its actors. Okay, think the same thing in a buy a beverage use case. The customer actually has to insert a coin and the machine displays the amount that is deposited. That is one set of messages, and this message basically repeats several times. You may be inserting several coins, okay, until you have enough money so that you can actually select an item. Then the customer pushes a button to indicate a selection. So you are trying to buy one of the beverages, say something, okay, so a Coca-Cola or a Pepsi or something. Okay. Then actually the vending machine dispenses the beverage and issues the change if necessary. Okay. So these are the set of messages which are actually happening within a particular use case. Some use cases have fixed sequence of messages, the way like I have explained earlier. Okay. But more often they may have some variations. In fact, several variations. Okay. Depending on the money inserted. Okay. The machine may return a change for you or may not return a change for you. Okay. So similarly, like there can be like other conditions as well, errors, exceptions, etc. Okay, so we'll be discussing about these things with this particular example in the coming slides. So assume like you have alternate sequence of messages. Okay, so typically one should first define a mainline behavior for the system, mainline sequence. Okay, for the particular use case. Then all the optional subsequences, repetitions, and other variations are to be considered. But you have to provide the description of all these things for having a complete description for a use case. Okay. So I quickly mentioned it, but then like let us also think about these things. Error conditions are also part of a use case. Okay. Say for example, if a customer selects a beverage whose supply is exhausted, the vending machine displays a warning message. So this is also an alternate message sequence for you. Okay, what happens if the items are exhausted? Okay, whatever the beverage you are asking is already exhausted. So these things we may see them as actually error conditions. Okay, but then like they are all part of the functionality. So they are error conditions to you, a customer. But a designer should actually plan for all these possible behavior sequences. Okay, what happens if the supply is exhausted? What happens if the person's answered some coins and then decides like I don't want to do anything and he will takes the money out? Okay, so he presses like cancel the transaction. Okay, or like say for example, all these sort of error conditions like we have to think about. So if we really go with this sort of use case description for it, okay, say for example, a detailed use case description should be provided for each and every use case. Now let us look at this buy a beverage use case in detail. So we already have defined the summary in one of the slides I have shown you. The vending machine delivers a beverage after customer selects and pays for it. Okay, that's the basic summary description for that one. Okay, so that's the summary. So for the use case, like you have to provide all these things. Okay, summary. And what are the actors which are actually trying to use this use case? This is a customer is the one. Okay, an actor who will be used. He will be interacting with this use case. There will be several preconditions for this use case. The machine is waiting for the money to be inserted. That is a precondition for that. And then there can be description. There will be a detailed description of that. So the machine starts in waiting state in which like it displays the message, enter the coins, and then the customer basically inserts the coins. The machine basically shows like how much money is basically accredited. Okay, and also like it basically has to light up all the items like whatever you can which you can purchase. Okay, once you start inserting the money, then say for example after inserting several coins like you basically the customer pushes that particular button, the machine then basically has to dispense the current corresponding item and then like it has to return the change. It has to first make the change and then like it has to return the change. Okay, provided the like the cost of the item is less than the amount you have already inserted. So this is all the description, detailed description of that particular use case. Okay, so this is in the direct sequence, the main sequence. But then there can be several exceptions. We already have talked about it. Exceptions are also the part of the functionality of that particular use case. Say for example, what happens if it is cancelled? If the customer presses a cancel button, say for example, after he inserted some coins before he even selected the thing, the money has to be returned and the machine has to reset and then like it has to come back to the waiting state, to the original state where the machine was before the use case has actually started. Okay, what happens if the stock is out? Okay, so that means like the items are finished, the beverages are finished, out of the stock. So if the customer presses the button, okay, so out of the stock message should be displayed. That item is out of stock, so it should be displayed. So you need to have some sort of screen somewhere. Okay, of course the message I mean the machine still should accept some coins. Okay, so you don't have to return back to the original state the way like in the case of this cancelled exception. You can still accept further coins so that like the customer can select a different beverage. Okay, you don't have to start that use case completely from beginning again when it is out of stock. Say for example like the customer has inserted, the other exceptions can be like the customer has inserted few coins. Okay, but it is not sufficient to buy a particular beverage. What you should be doing at that particular case, insufficient money. Okay, then you have to display some message like you must insert some more money. Okay, whatever the remaining money. Okay, so that information can be put and then like the state will, I mean like the machine will be still in that insert coins position. Okay, it can still accept more coins. What happens say for example the customer bought the beverage and then like you cannot deliver the exact change. Okay, so for example like of course for us like these things are almost done but then like a dollar will have a cent or a euro will have a cent. Assume like the remaining amount is 3 cents but then like that machine don't have 3 cents. We can't return 3 cents. It is still waiting for further coins. Say for example, you will enter 2 more cents, okay, into that machine, and then like you can have a 5 cent coin. Okay, so these are all like these exceptions, but then like they are part of the function as well. A detailed use case description should have all this information. Okay, similar to this sort of precondition, the way the machine is, we will also have the post condition. What happens after the use case is finished? The machine is again waiting for the money to be inserted. Okay, so it basically starts with that one. So this is about a use case description and an example. So the description should be so detailed actually. When you come to a complete use case model, okay, a complete use case model actually partitions the functionality of the system. We said like a use case, okay, basically defines a functionality of a system. In that sense, like if you have several use cases, you are basically talking about different functionality of that particular system. So that's how like use cases actually partition the complete functionality of the system. When you are defining use cases, they should preferably all be at a comparable level of abstraction. Okay. Say for example, when you are developing this telephone system, okay, so and then like use case make telephone call and record voice messages are at comparable levels. These two use cases, make telephone call and record voice messages, are at a comparable level. So that means like they have certain functionality, they need to have certain activities, they are at an equal level. To give an alternate example, like I mean like a contradicting example. Say for example, if you have another use case, if you define another use case, something like set external speaker volume to high, that is too narrow, isn't it? So it is not at the level of making a telephone call or like record voice message. To broaden such a use case, like what you can do is like set speaker volume can be one use case, like which can basically make it up and down and all sorts of things. You can basically do that one. Or else like you can have a much broader use case, which is like set telephone parameters. So then whatever the use cases which you are defining are at the equal levels, okay, at the comparable levels, comparable levels. So that's about the use cases. Then you will be basically drawing use case diagrams. UML basically allows these use case diagrams. In this case, like so these stick figures are the actors. Actors are actually shown as these stick figures. Okay, use case diagram basically involves these actors and the use cases. Okay, so the actors are the stick figures like this one. Okay, so and then like these use cases are shown like this ellipses. Okay, so in our vending machine system, like what are the actors we have as of now? So we have already seen several examples, isn't it? The customer is one actor, the repair technician is another actor, and the stock work is another actor. And we already have discussed about the main use cases. Okay, so we have given a quick description of each and every use case. Okay, so buy a beverage is one use case, perform scheduled maintenance is another use case, and if in certain cases like if the system is not being properly, if you have to repair, make repairs is another use case, and load items is another use case. And the customer is actually invoking this buy a beverage use case. Okay, and a repair technician can basically interact with this perform scheduling maintenance and schedule maintenance and make repairs. Okay, a stock clerk can basically interact with this sort of load items use case. So this is about use case models. Okay, as far as the reference is concerned, so we are now in chapter 7 of object-oriented modeling and design with UML. Okay, Michael Blaha and James Rumbaugh. Thank you very much for your attention.